Now that we've seen cube roots and fourth roots, we're ready to move on to the next topic, fractional exponents. We'll look at two rules, one at a time, that allow us to interpret fractional exponents. The first rule is that if we have something in the form x to the 1 over n power, what this means is the nth root of x. So this allows us to evaluate certain expressions that have fractional exponents. Let's look at some quick examples. Let's look at 25 to the 1/2 power. Now, if we use the rule here, which I'm going to box in to highlight it, if we use the rule, then what we need to do is we need to take the square root, because that's 1 over 2 as an exponent. So we've got the square root of 25. We usually don't write 2 when it's the index. We just assume that when there's no number written there, we're looking at a square root. And the square root of 25 is 5. So that means that 25 to the 1/2 power is 5. Similarly, we can look at 8 to the 1/3 power. This means the cube root of 8. And we know the cube root of 8 is 2, because 2 times 2 times 2 gives us 8. So 8 to the 1/3 power is equal to 2. Let's look at one more. Let's look at 81 to the 1/4 power. Here, if we write this as a radical, this means the fourth root of 81. So we're asking ourselves, what number can we raise to the 4th power to get 81? And the answer is 3, because 3 to the 4th is 81. So here, we're able now to evaluate expressions that have fractional exponents, but so far we've only seen examples where the exponent is 1 over a number. Let's look at the second rule that helps us deal with other situations. If we have x to the m over n power, we're still going to have a radical, and that denominator in the exponent is still going to be the index of the radical, but the numerator is going to stay as an exponent. So once we take the nth root of x, we raise it to the mth power. Let's look at some examples here. Let's look at 25 to the 3/2 power. If we rewrite this as a radical expression, it's going to be the square root of 25 cubed. We know the square root of 25 is 5, and 5 cubed is 125. 5 times 5 times 5. So 5 to the 3/2 is 125. Let's look at 8 to the 2/3 power. Here, this is going to end up being the cube root of 8 and then squared. The cube root of 8 is 2, and 2 squared is 4. So 8 to the 2/3 power is equal to 4. Let's look at 81 to the 3/4 power. Here, we need to take the 4th root of 81 and cube the result. The 4th root of 81 is 3, and 3 cubed is 27. All right. So in all of these situations, we have a way to interpret fractional exponents involving roots and exponents, and once we do that, we are able to evaluate them. Now, I want to point something out here. When we looked at the graph of the function f of x equals 2 to the x, we made a table of values to see what these points would be. We said x was 0, 1, 2, 3. We looked at some negative numbers. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8. But I conveniently avoided any sorts of fractional values of x because we weren't really ready to deal with those at the time. But now, if we look at fractional exponents like 1/2 or 3/2, we know now how to deal with these. If we have 2 to the 1/2 power, that's just the square root of 2, which a calculator can tell us is approximately 1.4. If we have 2 to the 3/2 power, that's the square root of 2 cubed, which is approximately equal to 2.8. So this opens the doors to evaluating an exponential expression where the exponent isn't an integer, and this is also going to be useful and important as we move forward and look at logarithms.